Have you ever wondered how it all began? How from nothingness, the universe as we know it came into existence? This question has puzzled humans for centuries, sparking countless theories and debates. The most widely accepted answer among scientists today is a mind-boggling event known as the Big Bang. This is not to be mistaken for an explosion, as the name might suggest. Rather, it was an expansion. Picture an infinitely small point, pregnant with potential. Now imagine it growing, spreading out in all directions at an inconceivable speed. This was the birth of our universe, a grand ballet of space and time dancing into existence. The Big Bang occurred approximately 13.8 billion years ago, a number so vast it's nearly impossible to comprehend. To put it into perspective, if you condense the entire history of the universe into a single year, the Big Bang would mark the strike of midnight on January 1st. And all of recorded human history would fit into the last few seconds of December 31st. Yet, despite its name, the Big Bang wasn't a fiery blast. In fact, it was quite the opposite. It was an expansion of space itself. From that infinitely small point, the universe began to grow, stretching and inflating like the surface of an ever-expanding balloon. This expansion wasn't smooth or slow, it was incredibly fast, faster than the speed of light. Space, time, matter, energy, everything was carried along in this rapid expansion. And as it expanded, it cooled, setting the stage for the formation of the first particles and the laws of physics as we understand them today. So, the next time you gaze up at the night sky, remember that every star, every galaxy, every speck of dust, and even the empty space itself, all started from that infinitesimal point. And it's still growing, still expanding even now, carrying us along on its cosmic journey. Thus, from an infinitely small point, our universe embarked on an extraordinary journey of expansion. And that, my friends, is just the start of our tale. Imagine a universe unimaginably dense and scorching hot. That was the reality in the first moments, so minuscule they're almost impossible to comprehend, just after the birth of the cosmos. In these initial seconds, a fascinating spectacle was unfolding. All four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, were one. This unified force dominated the earliest moments of existence. But as the universe began to expand, it also started to cool. This chilling effect caused the unity of the fundamental forces to shatter, each force separating and emerging in its own right. As they did, the drama of creation continued. The universe, now a bit less dense and a bit cooler, set the stage for the formation of the first particles. These particles, the earliest constituents of matter, marked a significant milestone in the universe's history. As the universe cooled, it paved the way for the first building blocks of matter. A fraction of a second later, the universe experienced a growth spurt, a phase we call inflation. During this brief period, the universe expanded at an astonishingly rapid rate, stretching far beyond the view of our most powerful telescopes. This wasn't a simple expansion of matter into empty space, but rather, space itself was stretching and carrying matter along with it. Cosmic inflation solved several cosmic conundrums. For one, it explained why the universe appears so uniform across vast distances. The rapid expansion smoothed out any variations in density and temperature, resulting in the remarkably consistent cosmos we see today. Inflation also played a significant role in the distribution of matter. Tiny quantum fluctuations in the early universe were stretched by inflation, seeding the cosmic structures we see today: galaxies, clusters of galaxies, and vast voids. Inflation set the stage for the universe as we observe it today. It's like the universe's own magic trick, a blink-and-you-miss-it moment that shaped everything we know. With further cooling, the universe witnessed the birth of the first elements. Let's picture this. As the universe expanded and cooled, it reached a point where subatomic particles such as quarks and gluons were no longer zinging around at breakneck speeds. They began to slow down and coalesce, forming the first protons and neutrons. These particles are the building blocks of atomic nuclei, setting the stage for the formation of elements. Now imagine a vast soup of these protons and neutrons floating around in the universe. This was not a random process, but one guided by the fundamental forces of nature. The strong nuclear force, one of the four basic forces in the universe, played a key role in this process. It's responsible for holding atomic nuclei together, and it was the glue that bound protons and neutrons into atomic nuclei. As the universe continued to cool, these atomic nuclei began to capture electrons, a process known as recombination. This was a crucial step in the formation of atoms, as it resulted in electrically neutral atoms that could exist in a stable state. The first two elements to form were the simplest and lightest ones: hydrogen, with 1 proton and 1 electron, and helium, with 2 protons, 2 neutrons, and 2 electrons. These elements didn't just appear out of nowhere, they were the result of countless interactions between particles, guided by the laws of physics. These first elements, hydrogen and helium, were not just the building blocks for stars and galaxies, they were also the seeds from which all other elements were formed. In the core of stars, through a process known as nuclear fusion, these simple elements are transformed into heavier ones like carbon, oxygen, and iron. Every atom in your body, the air you breathe, the food you eat, and even the device you're using to watch this video, all of it can be traced back to these first elements formed in the early universe. And so, the first elements, hydrogen and helium, came into existence. Fast forward a few 100 million years, and the universe was ready to light up. After the formation of the first elements, hydrogen and helium, the stage was set for a cosmic light show. This era, known as the Cosmic Dark Ages, was a time of great change. As the universe continued to expand and cool, clouds of hydrogen and helium began to collapse under their own gravity. These clouds formed the first structures in the universe, dense regions of gas that would eventually ignite to form the first stars. These weren't like the stars we see today though. These were behemoths, much larger and hotter, burning brightly and living fast. Their short, intense lives ended in spectacular supernovae, spreading heavier elements throughout the universe. These first stars didn't shine alone for long. Gravity began to pull them together, forming the first galaxies. These galaxies were smaller than the ones we're familiar with today, but they were the building blocks of the cosmic structures we see in the night sky. When we look up at the stars, we're seeing the descendants of these first celestial bodies. The galaxies we observe, like our own Milky Way, are the result of billions of years of cosmic evolution, with smaller galaxies merging and growing into the grand spiral and elliptical galaxies we see today. It's important to note that while we can't directly observe these first stars and galaxies, we can see their influence. Their formation ended the cosmic dark ages and began the epoch of reionization, a time when the fog of neutral hydrogen that filled the universe was ionized by the light of the first stars and galaxies. The birth of these celestial bodies marked a significant turning point in the history of the universe. It was the beginning of the complex cosmic tapestry we see today, a testament to the incredible power and beauty of the cosmos. The first stars and galaxies were the ancestors of the celestial bodies we marvel at today. From a single point to the vast cosmos we call home, the journey of the universe is a testament to the incredible laws of physics. We've traced the path of our universe from the moment it sprang into existence, around 13.8 billion years ago, with the Big Bang. This wasn't an explosion but an expansion of space itself. In its first moments, the universe was unimaginably dense and hot, with all 4 fundamental forces unified. As it expanded and cooled, these forces separated, and the first particles formed. A fraction of a second later, the universe underwent a rapid expansion known as inflation, setting the stage for a uniform distribution of matter. As it cooled further, protons and neutrons formed, eventually creating the first elements, hydrogen and helium. Fast forward a few 100 million years and the first stars and galaxies came into being. Thank you for joining us on this cosmic voyage. Until next time, keep exploring and stay curious.